So if you've got your review out, you might want to have some paper so you can do the review with me. I'm going to put some stuff up on the board. The test will have 30 questions. Some of them are multiple choice and some are true and false. Be careful on the true and false. So first of all, we need to know what makes up an ionic compound. What makes an ionic compound? This is where we're using our brains and trying to answer. Yes? Okay, it is held by an ionic bond, but what is an ionic bond? Okay, so we have, for instance, calcium that might have 2 electrons in its outer shell, and we might have sulfur over here that has 6 in its outer shell, right? We did this before, where we say, okay, this electron's going to go here, and this electron's going to go here, and because they move, we now have a charged particle. Calcium becomes, that's lovely calcium, 2+, and sulfur now has a full outer octet of electrons, but because it does, it has a 2- charge. And they are electrostatically attached. They do not share electrons between them. It's because of the charges that they make an ionic bond. Okay, so the bond that is made is electrostatic, meaning it has to do with the charges attracting each other. Okay, so I think electrostatic, I think of a balloon I'm trying to static onto me. Okay. In order to do an ionic compound, we have to have 2 different things. We have to have a metal, and we have to have a nonmetal. We don't want to have anything but that. If we have 2 nonmetals, it won't work. If I have 2 metals, it won't work. If I have a metalloid and a nonmetal, it won't work to be an ionic bond. It has to be a metal and a nonmetal. Okay? All right. So if I were to give you a list of chemicals, could you tell me what is ionic and what is not? Let's see how well we do. Okay, which ones of these would be considered ionic? Shout out if you know one of them. Which one? Top one, yes. Second one, yes. There's more up there. The third one, yes. There's another one up there. And the last one, how did you decide all that? Farther apart they are in the periodic table, the more chance they're ionic. As they get close, remember our line between boron, the diagonal between boron and oxygen, that staircase, that's our dividing line between our metals and our nonmetals. So even though lead looks like it's getting close to the other side, it's below the staircase right here. So it is a metal with a nonmetal, so it would be considered ionic. Okay, it is actually getting more towards polar covalent, more covalent than ionic, but it's still considered. Okay, we all right with that? Okay, so what is a cation and what is an anion? This is how I remember it. Cats have paws. So this is my cation, and from the original atom here to a cation, it actually decreases in size, so it gets smaller because it's given off electrons, so it becomes smaller. Okay, my anion, which is this other side, anion started here, but when I finished, it actually got bigger because it gained more electrons. Okay? So as a negative, it got negative because it got bigger. Thinking about that prom dress or trying to get into a clothes. Okay? All right, so let's go forward. We talked about what makes up an ionic compound, metal and a nonmetal. Understand what an ionic bond is. It's electrostatically attached, meaning oppositely charged. That's what holds the compounds together, is you have to have opposite charges, not the same charges, opposite charges. Understand what an ion is. An ion is just something that's gained or lost electrons. Okay, so like on our calcium, it had lost electrons, so it became an ion with a 2+ charge because it actually lost its electrons. Okay, determine what noble gas it would be isoelectric to. So we did calcium and sulfur. We put sulfur up here. So sulfur ended up like this. We need to be able to look at it and say, okay, what noble gas is it now like? So on calcium, we now have taken these electrons away, right? So what would calcium be like if it lost 2 electrons? What noble gas? I heard krypton, I heard argon. Which one is it? If I lose 2, then I go back to, so from 20 I go 19, 18. So it should be argon. So it is like argon. Now, originally its electron configuration was 1s2, 2s2, 2p6, 3s2, right? 3p6, 4s2, right? Did I do that electron configuration right for calcium? But when it lost 2 electrons, it loses these 2. So I need to be able to write the electron configuration for the ion. So the ion would be 1s2, 2s2, 2p6, 3s2, 3p6, because it's just like argons. Okay? So really quickly, give me, or write down, the electron configuration for sulfur, and then fix it. Tell me what noble gas it's like, and give me the new electron configuration. So practice. Give you another minute to finish. Okay, so originally we should have had 1s2, 2s2, 2p6, 3s2, 3p4, correct? When we added 2 electrons, we end up with 1s2, 2s2, 2p6, 3s2, 3p6, which again is argon. Okay, anybody having problems with that? Need me to do another one? Okay? All right, so basically what we're saying is it's isoelectric with, meaning it has the same outer shell as that one. Okay, be able to determine the number of electrons that an ion has after gaining and becoming an anion, or losing and becoming a cation. So we could just add up how many so sulfur was at 16. The -2 means I added 2 more, it would have 18 electrons. Remember, protons do not change, and to get your mass number is just your protons plus your neutrons. Okay, be able to write an ion of an element given the protons and the electrons. So if I wrote up here on the board that you had 43 protons and 38 electrons, write the ion for me. Okay, should have had a chance. What element is it? Technetium, Tc, right? So I'd write Tc. What charge does it have? It has a positive what? So it has a 5 plus, right? So you should be able to do that given that information. Okay, let's do another one. Say that I have 33 protons and 36 electrons. What ion would this be? Okay, it would be arsenic. So As, what charge would it have? 3 minus, good. Okay, so we should be able to really quickly find that. Be able to predict and write the ion for any element when given its name. So if I'm given a name like, whoops, helps if you spell it right. How would I write that? Okay, you're right. Te, so we find tellurium. It is number 52 on the periodic table. It's 2 away from being a noble gas, so we would put 2 minus because it needs 2 to become like a noble gas. Okay, what if I said, what would this one be? So strontium is Sr, and it only has 2 in its outer shell, so we're going to get rid of those so it can become like the noble gas below it, so it is 2 plus. So given any name, you should be able to give me what charge it might take. Now, she'll probably just stay in the A's, which are the S and the P. Okay, why wouldn't she go to the D or the F? There's lots of different charges, right, for that. Okay, you need to be able to predict given the group numbers. So as we look at the periodic table, this was our S block, here's our D block, and here's our P block, and then the F block. This is known as the B group. These are the A group. So this is 1A, 2A, 3A, 4A, all the way to 8A. Our table has it 1, 2, and then when you get here it's 13, 14 to 18. So all you have to just remember is the outermost S and P. Those are your A groups. Okay? So if she asks 8A or 7A, what if I say, what would the most likely charge of group 5A be? So 5A would be what one? Which family? Nitrogen's family. So which would be the most likely for that family? 3 minus. But it could take what else? 5 plus, right? This one is not as likely as a 3 minus, but it's still possible. If she asks you for the most likely, you go with the 3 minus. Yes?
So if it's
plus or minus 4. It's equal to gain or lose. Cation is positive, so it would be the positive one. Anion is the negative. Right. So carbon's column will go with either side of it. So if it goes with something that takes a negative charge, it will become positive. If it goes with something that takes a positive charge, it will become negative. So they'll balance it out. Okay, so you need to be able to do that. If they said, for instance, here is an element, and here is another element, and they're to go together as a chemical formula, what chemical formula should I make with that? First of all, what charge would X take? Good, 3 plus. And what charge would Y take? It wants 2 more, right? So it'd be 2 minus. I look at that and I say, okay, what's a common factor? 6, right? So how many X's do I need to make 6? How many Y's do I need to make 6? None. Okay, don't let that mess you up. Okay, you should also be able to say, if I was given something in 2A and something in 7A, call this one A, call this one B, what would my formula be? Well, again, what's my charge going to be if it's in the 2A column? 2 plus. What's my charge going to be if it's in the 7A column? 1 minus. How am I going to put them together so they add to z equals 0? I need 2 B's. Good. So you should be able to tell them really quickly what's going on. Okay, be able to predict any charge of the element by its group number. We already went over that. So column 1A would be 1 plus 1 or 1 plus. 2A would be 2 plus. 3A would be 3 plus. 4A would be plus or minus 4. That kind of thing going on. All right, be able to determine if 2 elements will form an ionic bond by their position on the periodic table. So if I gave you these 2 elements, will they form an ionic bond? Okay, Jacob says no. Why? Germanium's a metalloid, and what do we need for an ionic bond? Metal and non-metal. Okay, so what about if I just give you symbols here? Have I written them in the right order? That you would write them in the, good. The Fe would go first, and yes, it would make an ionic bond. How about, no, they're too close and they're above that diagonal line. So you need to be able to do that really quickly. Not really quickly, but you need to be able to do it. Okay, so if I were to put these 2 together and I ended up with this formula, how do I name it? Iron, what? Iron 2 oxide, huh? We're just going up in number. Iron 2, iron 3. You guys do know that you do need a Roman numeral. What does that Roman numeral tell you? The charge. Be careful because she might say that it might be how many you have. It might be how many of the product you have. It might be how many of the oxygen you have. Make sure that you know that it is the charge on the one before it, right? So up here, we know we have 3 oxygens. Oxygen's a minus 2. We also know we have 2 irons. We don't know what the charge is. We know that has to add to 0. Well, I have to make each of them 6, right? Because the one's already negative 6. So that means this has to be a 3, right? Roman numeral 3, and I'm done. Okay, so let's do another one. Let's do, how do I name this one? Tell me. Sodium oxide. Why didn't you put a Roman numeral? Okay, it's what I call type 1, right? These ones don't have different charges. So it's first column, second column, not including hydrogen, and your slide. Remember your slide, boron, aluminum, gallium at +3, zinc at +2, silver at +1. These ones don't have a different charge. So we just name it. We don't have to worry about the Roman numeral. Okay, what about this one? I should use something different besides oxygen. I will next. I'm just stuck on oxygen. Okay, W is what? Tungsten, okay. Roman numeral or not? Okay, space for Roman numeral. How do I end it? Oxide, okay. How do I figure out the Roman numeral? Well, oxygen's a -2, and I have 5 of them, plus 2 times some number also has to equal 0. So this has to be 5, right? So Roman numeral for 5 is a V. Okay, let's do something that doesn't have oxygen in it. Let's do... I don't know if that's a real compound. We're just making stuff up. Okay? Probably not, but that's okay. I pretend. Okay, so the first name is chromium. Good. I think there's an N in there, but that's okay. Roman numeral something. And then chloride. And I made it difficult for you because we know chloride is a -1. We have 7 of them, plus 3 times equals 0. This one's a little bit difficult, I will say that. This one is actually a 2, 3. I gave you a hard one, I'm sorry. You won't have one of those on the test. So you would have 2 that are at a +2. Okay, so 2 at a +2 and 1 at a +3. That's how you would get your 7. And there are chemical formulas like that, but don't worry about it. That's not on the test. I gave you a hard one, sorry. Okay, so let's do another one that's not so hard. Okay, iron chloride. Roman numeral or not? Roman numeral 3, because chlorine has a -1. We have 3 of them, plus what number has to equal 0, right? Okay, let's put a polyatomic up there. We haven't done a polyatomic yet. So let's try... What's Mn? Manganese. Got to be careful. Okay, Roman numeral or not? Roman numeral, leave a space. SO4, what's that? Sulfate. You will need to know your polyatomics. Either put them on your periodic table or memorize them. Sulfate has what charge? -2 plus 2 times some number has to equal 0. So what's that some number? 3. Done. Okay, do we need to do another one, or are you doing okay? Do a few more, okay. So let's do, I'm going to go backwards. I'm going to give you the name. You give me the formula. Okay, so we'll switch it up a little bit. I think I spelled that wrong, but that's okay. It's in the D. You're having a hard time finding it. It's okay. Okay, so molybdenum you should have written a capital O and a small, or capital M small o. Phosphite was PO3, has a 3 minus charge. This one had a 2 plus charge. Common factor is 6, so you should have put molybdenum as having needed 3, parentheses around the PO3 with a 2 on the outside. How do we do? You're close. Okay, let's do a couple more like this. Okay, let's do if I didn't put a Roman numeral, where does it have to be? Columns 1, 2, or the slide? Okay, GA. What's the charge on GA? Let's do that first. 3 plus. Okay, what's the charge on, what is sulfite? SO3 with what charge? Okay, common factor is 6, so how many GAs do I need? How many sulfate groups do I need? That's why they're in parentheses. 3. Okay, we ready for another one? Okay, let's do so if you don't know your polyatomics, those should be written on your 3x5 card, because you won't get them on the test. Yes? Nope. Not the ones you're allowed now. I know. Okay, so yttrium is what? Y. What charge is it? What charge is it? 4 positive. What is nitrite? NO2. What charge does it have? -1. So, what's my formula? Y. Okay. How about this? Okay, SR has what charge? What is cyanide? What charge does it have? Okay, how many of each do I need? SR, parentheses, CN, parentheses, close 2. Good. All right, how about Okay, Ti has what charge? Okay. Good. Make sure you put it in parentheses and you're good. All right, so you should be able to go back and forth like this. Pretty easy. Next set here, you need to be able to determine charges on any element given the chemical formula. So if I give you, for instance, you should be able to tell me either charge for either one of those elements. So what's chlorine's charge? -1. What's tungsten's charge? Come on, you got this. If you know chlorine is -1 and you got 5 of them, these have to add together to equal 0, right? So what's tungsten's charge? 5 positive, right? Okay, so if she gives you something that you haven't seen before, and she might give you a polyatomic you don't know about, I'm just going to put a bogus one up here. If I say this, oh, don't want to do that. And I ask you to tell me what the polyatomic is and what the charge is, what would you write? Okay, what do I know? Let's go there. What do you know? Out of all this garbage right here, what do you know? Barium is what? Barium is a +2. How many do I have? I have 2. I know that this has to add to whatever this is to equal 0, right? So what's my polyatomic? X, Y, 2, Z has a 2 negative charge. Okay? Because I know barium doesn't like to make groups, so whatever's left over has to be the group, right? So whether she puts parentheses around it or not. So let's do another one. Say that I have this. I'm trying to make up letters here. Okay, how would you figure that one out? And if you go looking for B, Y, and Z on the thing, we're in trouble. Okay, you should know that some of them are bogus. So first of all, what do I know? Aluminum is a +3, yeah. So I have +3, there's 2 of them. I have this, I don't know what is, but I do know it adds to 0. What's the charge on that? They have to add to equal 0. So I have 6 plus what equals 0, guys? -6. So I'm going to go By2Z has a 6 negative charge. Okay? All right. Let's see. You need to be able to take, I think we already did the Lewis dots. Did we do the Lewis dots? I can't remember. So take a Lewis dot like this and put it with another one and be able to write the chemical formula for it. So what I would do if it were me, is say, okay, what would X charge take? What would be the charges it could take? Because I'm doing charges because it has 4, right? So it can go either way. So it could be a plus or a -4, right? What would Y take? 3 minus or a 5 plus. What is it most likely to take? 3 minus. So I'm going to ignore that. This one is then going to be my plus. So how would I write the formula for this one? Well, what's a common factor? 12, right? How do I get X to 12? 3 times it. How do I get Y to 12? 4 times it. So you should be able to do that, okay? And write it according to fictional elements, because those are fictional elements. Be able to name the compound with the polyatomic ions in them, know the polyatomic ions, and understand what a polyatomic ion is. Polyatomic ion is a group of elements that hang together and have a charge. So they could be a cation or an anion, but they have a charge. Remember, mercury 1 is Hg2 with a +2 charge, or 2+ charge. Be able to determine the charge and formula of an unknown polyatomic. We've just been doing that. And understand why the Roman numeral in type 2 naming represents. So don't be messed up when she said when you have something like tungsten 5 oxide. This doesn't tell me how many I have, but it tells me the charge, which is 5+. Okay, make sure you're okay with that. True and false are high stakes questions when you go into a test at the college. Make sure you read and understand the question before you mark it true or false, because it's 50% you could get it right, 50% you could get it wrong, which is high stakes. There are 30 questions. Like I said, I think there are 8 to 10 true to false. The rest are just naming. Make sure you're understanding what she's talking about. Okay, what I have done for you is on your Weber, and it went to the other screen, so I was playing with it. On your Weber canvas, if you go into, sorry, I got grades up, so I got to go home. If you go into Chapter 3, Daily Work, and you go down to today's date, I've put on there Khan Academy help and quizzes. So if you go to Khan Academy, you can go back and you can look at some videos they've got on naming if you're still having problems with that. But they also have down at the bottom 3 different things. One where you can practice yourself to see, am I getting the right ion? And I want to go forward. There's one where you can practice just regular ionic compounds. And if you need a hint, you can give hints. You can check again. You can try one, then check it, and they'll tell you if you got it right or wrong. So it's helpful because these are the kind of things that she would be doing. And then they've got it where it's the type 2. So you can practice doing that. There are many, many, many sites out there that have you practice naming ionic compounds or writing ionic compounds. If you're having problems, use one of those to get up. Now, last little blip, because this really bothered me. Okay, and I'm going to bug you again. Isaac, don't fall asleep. Okay, you guys need to do your homework. You need to do your Learn Smarts. You need to do your homework, and you need to turn them in. You have till tomorrow night on all of them, 1 through 3, A through S. You've got to get them done and in. I cannot open them again. I begged and pleaded to get them open as it is. All you have is till tomorrow night, 11:59. Get them done. I have many people here that I could call out in this class just in 3S. 1, 2, 3, 4, 5, 6, 7 of you. In 3A, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And I could go on. So please get your homework done. Get your Learn Smarts done. You don't want to give those points up. We are turning in labs now electronically. So if you need to borrow my iPads to turn them in, turn them in. Okay, if you need to redo 1 through 3, get them done, turn them in. Need to turn in the one we just did, physical chemical, which is our 4th lab. Take it and turn it in. PDF works a lot better than JPEG. JPEG, I'm cussing. I will take it if that's all you can do. But this will do PDF, and I'll be much happier, and they get a lot better pictures. Questions? Okay, the rest of the period is yours to get your dang homeworks done, your Learn Smarts done, and or the lab if you need to finish it. Okay, and get help. 3x5 cards are here. You remember you get one side only. Okay? All right. Good. Now get your work done. Okay, I'm going to stop this video.